Well, now we're going to go charging ahead. So if C is a smooth curve represented by a vector valuing function r of t on an open interval I, and if t prime of t is not the zero vector, remember what t prime, or remember what t is. T was, if you recall, our unit tangent vector, r prime over the length of r. So if t prime is not the unit vector, is not the zero vector, then the principal unit normal vector at t is defined to be, the normal vector is t prime of t over the length of t prime of t. Now that will convert it to a unit vector, because t prime, there's no guarantee that t prime is going to be of length 1. So we divide it by its length, and then we've made a unit vector. And that's called the principal unit normal vector. Note that the unit tangent vector points in the direction of motion at time t, and the normal vector is orthogonal to t of t, and points in the direction that the object is turning. And there's an example, or example 1, here we have it. The tangent vector, the unit tangent vector, is pointing in the direction of motion at t equals pi over 2. The normal vector is pointing the way the object is turning, and you can probably look at the sketch and see, yeah, they do look like they're orthogonal to each other. In other words, their dot product would be 0. So, find the principal unit normal vector at t equals pi over 2, our good old same old function. And first we find the unit tangent vector by finding the derivative of this. Well, we already did that earlier. So there's that derivative. And here's its length. And, well, now it gets ugly, I confess. Now it gets very ugly, because if I wanted to find t prime of this, I've got to find the derivative of this, and then it would be negative 2 sine of t over this square root, plus 3 cosine t over this square root, and then plus 1 over this square root. And I have to find each one of those derivatives, and admittedly I'm intimidated by that, so I'm going to use my software. And just even if I use my software, look at the size of this thing. Here is the this to the 1/2 means square root. Here it is, worked out, and that is admittedly very ugly. Here it is. Here is me trying to simplify it a little bit. And finally, we need, dare I say, to find the unit normal vector, we've got to find the derivative of the unit tangent vector divided by its length. Well, that proves interesting. So here it is, the length of that vector. If I can show this to you, right there it is, there's all that. And you see the 2 double bars on the sides, that's the length of that vector. So, wow, what a mess. So, it's ugly, ugly, ugly. But if we let t equal pi over 2, as you recall, then the cosine of pi over 2, so this is 0, 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 and maybe we'll get somewhere. And if you do all that I said, believe it or not, all the things that happen, this is 4 times, don't forget sine of pi over 2 is 1, so we got 4 plus 1, so in the numerator, and square root of that. So, oh dear me. Trust me, I think I'm intimidated by trying to eke all this out precisely, but I'm glad for software. If you have a TI 89, I bet you're glad of that too. But that can be done. Where's that negative 3j coming from? good gracious. It's coming from here. Divided by, okay, there's the vector divided by its length eventually. So wow, is this ugly, 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 but we can do it, and it does come out better than you think. And the nice part is what does come out is this 3 over the square root of 5 is in the numerator and the denominator. Of course, it's squared there, but you take the square root of it before you square it, so it's still, the whole thing is the normal vector. This particular normal vector turns out to be negative j. If you recall back up here, if you looked at it, that would be a precise description of this vector, negative j, remembering that this is the y-axis. Yeah. Warning, no exam questions will be like this, okay? For a much simpler problem, look at example 4. Oh, I don't have the page right. Look at example 4 from 11.4. The page is different because the edition of the book is different, but I think they didn't change their example for that.